Okay, so I am hoping that we have all finished the sketches of sine, cosine, tangent, and their reciprocal graphs. But we're going to concentrate mainly on sine and cosine, and so I'm going to be pulling those graphs to kind of show you, make sure we have those right. But we're going to start today doing transformations of those graphs. And this is just like any other parent function. So the changes will be just like the changes we've done with every other function since the beginning of the school year. So first of all, if there is a number out here in front of your function, then that's going to be a vertical stretch or shrink by a units. If there is a number inside the function, then that's going to change the graph horizontally, a horizontal stretch or shrink. And remember, we always do the opposite of what this says. So if it was times, we would divide, and we'll get to that. If there is a negative out front, we know that that causes the graph to reflect across the x-axis, and a negative on the inside of the function reflects across the y-axis. So when x changes, we reflect across the y. When y changes, we reflect across the x. So in order to do these notes today, we're going to need some points off of the sine and the cosine graph. And these are the points that you're going to need to memorize, just kind of like you memorized the ratios for sine and cosine to x, y, and r stuff. So we need to know where the sine graph starts, at the origin. What is that point? So when I look at my sine graph that we did in yesterday's notes, the sine graph at the origin is at 0, 0. Now I'm going to skip to the end of the period. You see it says the end of the period. That's one rotation around the circle, so that means at 2 pi. So at the end, we're at 2 pi 0. And then halfway through that period, so halfway through from here to here, we're at pi 0. And then at a fourth of the period, well, that's going to be halfway in between here, which is at pi halves, we are at 1. And at 3/4, which would be between here and here, which is 3 pi halves, we're at -1. So every time we start to graph one of these, you're going to need to know these points. The sine graph starts at 0, 0. It goes up first. The curve goes up to pi halves 1, comes back down to 0 at pi, goes down to -1 at 3 pi halves, and then it ends at 2 pi 0. All right, so if I have those points, then if I make these changes, this just tells me to multiply the y's by 2. Well, multiplying 0 by 2 still gives me 0. Here, if I multiply 1 by 2, I get 2. Here I have 0 again, so it stays 0. And here I'm going to get -2, and then 0 stays 0. So if we think about the graph itself and what would have happened if we sketched these points, instead of my graph going up at pi halves to 1, it would go pi halves to 2, it would just be much taller, but still come down to -2 back to 0. So this would make the graph taller. If I multiply my y's by -1, or by a negative, 0 is still 0. Pi halves, 1 would be pi halves -1. Pi 0. 3 pi halves +1. 2 pi 0. So here, the 1 changed to -1, the -1 changed to +1. So what that did was, instead of the graph going up first and then down, it would go down first and then up. And then last, if I multiply by 1/2, 0 stays 0. Pi halves is now going to be 1/2. Pi 0. 3 pi halves, -1/2, 2 pi 0. All right, so instead of it going up to 1, it's only going up to a half. Instead of going down to -1, it's going down to a -1/2. So this graph would just be a little shorter. Instead of going up to 1, it would be a half, just a little bit shorter graph. All right, so I'm going to go ahead and help you get started with the original points here for cosine, just like we had the original points for sine. Now, your graph, when you got finished with it, should have looked something like this. So at the origin, at 0, we're up here at +1. So this graph starts at 0, 1. And at the end, we're at 2 pi 1. And halfway in between, we're at pi -1. And at a fourth of the way through, we're at pi halves 0. And at 3/4, we're at 3 pi halves 0. So what I'd like for you to do is go ahead and fill out this chart. It's almost exactly like that one. We're going to multiply by 2 in the y's, multiply the y's by -1, multiply by the y's by a half. Go ahead and fill out the chart, and then we'll check it and see how you did. Okay, so let me just go through the highlights. Hopefully you filled all this out, not just copied it, but here we're multiplying by 2 in the y's, so this would become 2. Here we would have -2, and at the end of the period, 2 pi 2. When we multiply by -1, the 1 becomes -1, -1 becomes +1, 1 becomes -1, and when you multiply a half, 1 becomes a half, -1 becomes -1/2, and 1 becomes a half. So again, the graph itself would change by stretching it or making it taller here. This is going to reflect it across the x-axis, and this one is just going to make it shorter. So in conclusion, if I have a number out in front of sine or in front of cosine, that number, we're going to multiply the y values by a. And it will either shrink or stretch or reflect the graph. Multiply the y values by a. Okay, for problem number 3, we're starting off with the original points for sine again. So sine starts at 0, 0. Then we go to pi halves, and it goes up to 1. Then we're at pi 0, 3 pi halves, -1, 2 pi 0. And we need to get really good at naming those original points. Okay, so now if you look, the number is inside the function. And I know there are no parentheses here, but this is a part of the angle theta inside the sine function. So this is inside the parentheses here with x. And anytime we're inside these understood parentheses with x, we kind of do the opposite, right? Everything's opposites. So when it says 2 times x, we're actually going to divide x by 2. So 0 is still 0. Here we have pi halves divided by 2. Now dividing by 2 is the same as multiplying by 1/2. So it might be easier to think of multiplying by 1/2 than dividing by 2. If I multiply this by 1/2, then I get pi over 4. Here, if I divide by 2 or multiply by 1/2, I'm going to get pi over 2. Here, if I multiply by 1/2, I'm going to get 3 pi over 4. And here, if I multiply by 1/2 or divide by 2, the 2's divide out, and I just get pi. So the x values are the ones that change. And remember, it's opposite. So if it says 2 times, we're going to divide by 2 or multiply by a half. So when it says 1/2 times x, then really we're going to multiply by 2. We're dividing by 1/2 or multiplying by 2. So I feel like multiplying by 2 is going to be our easier concept to use. So if I multiply by 2, 0 is still 0. If I multiply pi over 2 times 2, pi over 2 times 2 over 1, I'm going to get 2 pi over 2. 2's divided out, I'll just get pi. If I multiply pi by 2, I get 2 pi. Multiply 3 pi halves times 2, I get those divide out, or you can do 6 pi over 2 and then it divides out. I get 3 pi. And if I multiply 2 pi by 2, I get 4 pi. Now, on all of these, you will end up seeing a pattern develop. So here, I go from 0 to pi fourths to pi halves. Pi halves, everything's jumping by a fourth, another fourth, another fourth, another fourth. Here, the pattern, I go from 0 to 1 pi to 2 pi to 3 pi. Once you see that pattern develop, if you want to use that, then you can. But what we are doing when we have a number here in front of x is we're going to do the opposite. We are going to divide x by this b value, or multiply by 1 over b. All right, so in our last example, it has numbers here for a y change and an x change. So we're using the cosine graph. The original points for cosine are 0, 1, pi halves 0, pi negative 1, 3 pi halves 0, 2 pi 1. So again, we need to work on memorizing those original points. Now, I'm going to do the y values first. So we're multiplying the y values by negative 2. So 1 times negative 2 would be negative 2. 0 times negative 2 is still 0. Negative 1 times negative 2 would be positive 2. 0 times negative 2 would be 0. And 1 times negative 2 is negative 2. For our x's, we're going to divide by 3. Divide x by 3, or multiply x by 1/3. Okay, so 0 divided by 3, or 0 times 1/3 is still 0. If I want to do this by 3, divide by 3, that's kind of tough, but multiply by 1/3, that's easy. I get pi over 6. Divide by 3, or multiply by 1/3, I get pi over 3. Multiply by 1/3, I'm going to get 3 pi halves times 1/3 gives me 3 pi over 6, reduces to pi halves. And then divide by 3, I'm going to get 2 pi thirds. All right, so now we want to plot those points. So it's important that you understand the same thing we did yesterday. This is marked off in units of pi on the x-axis. Remember, this is 1/6, 2/6, or pi thirds, pi halves. This is 4 pi 6, or 2 pi thirds, 5 pi 6. Everything is 1/6 on here. So every block is pi 6. So let's start plotting some points. Here we got 0, negative 2. All right, well, 0, negative 1. So negative 2 is going to be 4 blocks down. Then pi 6, that's my first mark over, and I'm at 0. And I want you guys to notice the spacing between those two. Now the spacing between the first and the second dot is just 1 block. That spacing will stay the same. So if you're not sure about pi thirds, but you're sure you got this, then just go 1 more block over, and we're going to go up 2 units. But remember too that pi thirds is 1/626, 2 pi 6. So this is the pi thirds line. Then we have pi halves, it's marked 0. And then 2 pi thirds, which is 4/6, is the next mark over, and we go back down to -2. And these are the points that start and end this graph after the changes have been made. Now remember, this is supposed to be a curve, not a V. So when you join those points together, it should look like a curve. Now, since this is one time around the circle, if you want to draw it again, you can. You can just repeat the pattern. One block over, back up, back down, and you can draw all the way across the graph if you want. But I'm really just on this set of notes looking for the original graph. All right, so now it asks us up here for domain, range, and period. Well, the domain, like I said, I could draw this all the way across. The domain is going to be all real numbers. The range for this graph, it goes down to -2 and it rises to +2. So my range goes from -2 to 2. And the period is talking about the end of this first graph. And the end of the period, you can always find right here. You're going to use this x value. The end of the period is at 2 pi thirds.